Okay, I'm just going to take a second to set this up, so just bear with me. Even though I'm the only thing between you and lunch, I'm very sorry. It's the opposite. Okay, this one's coming over here. I promise to try my best to take exactly 1/2 hour, though, so you can count down until the end if you want. Also, I tend to speak much more quickly than I expect to, so it might even be less than 1/2 an hour. Okay, I think this is going to work. Okay. Hi, everybody. I'm Christie Wilson. I'm a software engineer at Google, and I'm a co-creator of the Tekton project. I've worked in a lot of different industries throughout my career. I've worked in AAA games, mobile, and foreign currency exchange, and I think my microphone is just... Can you hear me okay? There's no cutting out or anything? Okay, cool. So regardless of what industry I've worked on, I've always ended up gravitating towards CI/CD related work. And I think there's a couple different reasons for that. One is because no matter what you're doing, there's always CI/CD involved. And the other is because there's always so much pain involved in the CI/CD, and there's always so much potential to make it better. So what I'm going to talk to you about today is how I think that cloud-native CI/CD can really take away a lot of that pain and kind of move CI/CD forward for us. So this is an overview of how we're going to spend that 30 minutes, or possibly less, because I think I'm already speaking faster. First, I'm going to go through what I mean when I say cloud-native CI/CD. And then I'm going to talk about Tekton, which is a cloud-native CI/CD project. I'm going to talk a bit about how it's built, because it's built on top of Kubernetes. And then I'll tell you how exactly it works. I'm going to give you a demo. And then we'll talk about what's coming next for Tekton. OK, so cloud-native CI/CD. I think we've already seen at least one definition of cloud-native. So I'm going to try to give you another one. I think if you ask 5 different people, you'll get 5 different answers. So on the one side is kind of a summary of the CNCF's definition of cloud-native. It always comes down to microservices and containers. Those containers are orchestrated dynamically, and we try to optimize resource utilization. So for a lot of us, it ends up looking like containers that we run on Kubernetes. And I'm not going to go into too much detail about how Kubernetes itself works, but you can, if you don't have experience with it, you can just think of it as a thing to orchestrate containers. But as we've seen from kind of the progression from monolith to microservice, the architectures that we make with cloud-native systems are kind of more complicated than what we had before. To try to prove that to you, this is my attempt to recreate the architecture of the first system that I worked on in software. It was model view controller, which I thought was pretty complicated at the time. Everything was written in Perl. And the applications I worked on connected to like 2 different endpoints. They'd connect to a server that handled user data and a MySQL database. And that was pretty much it. I have no idea how the software was released. That was not part of my life. But what was part of my life was sometimes having to SSH into the machines directly to fix problems in production. I remember once someone sitting next to me had a cold, and he dropped a Kleenex box on his keyboard and deleted a production database. At least that's what he said happened. I think that he might have been more complicit in that than he claimed. But so it was a time when things were kind of scary and risky, but they weren't really that complicated. But then if you look at the kinds of systems that we're dealing with today, a lot of that risk is gone, but there's a lot more complexity to deal with. So one application that you're working on could involve many microservices. They could all be written in different languages. All of those microservices have to be built and published somewhere. They have to be able to find each other once they're running. And if you're dealing with something like Kubernetes, then you're dealing with layers and layers of configuration. All of that configuration is hard to deal with, so then you add templating on top of the configuration, and it can be very hard to point at any particular config file and be like, that's the config file for production. So there's an awful lot going on. It means that you can start out wanting to create a web server, and then what you end up with is you're deploying and managing Kubernetes, Istio, Knative, Helm, and Spinnaker. It's a lot to deal with, and it's constantly changing. But the upside is that I think, at least, that it's all worth it. And one way that it's worth it is that it lets us have cloud-native CI. So this is my personal definition of what cloud-native CI is. Cloud-native CI is serverless. It's made up of open specifications and standards. You don't have to worry about what infrastructure it runs on. There's less fragmentation because we have reusable components. And we can also apply the software engineering best practices that we use for the rest of our code to the CI itself. So I'm going to go into, we're going to hear yet another definition of serverless. This one, I think, is different than the one that we heard before. When I say serverless in this context, I'm talking about not having to worry about the way that your workloads are executed. Before serverless, if you wanted to run a workload, you'd have to back it up with actual hardware. And you'd have to worry about things like running the right operating system, having the right kernel installed, and you'd have to manage the processes themselves. But if you're using a cloud-based service, you can request resources on demand, and most of that stuff is abstracted away for you. So that's what I mean when I say serverless in this context. And this means a lot for CI. Before having serverless, CI systems were monolithic. So either you'd have everything running on one box, or you'd have to add the additional complication of having like a master node and then worker nodes, and you had to coordinate between them. And if you're running things on one box, like many people know from using like Jenkins, as it still is today, you can actually have jobs on the same box interfere with each other. So there's a lot of complication, and it's difficult to deal with. But serverless makes that a lot easier. The next benefit of cloud-native CI, in my opinion, is the thing that I think makes Kubernetes really cool. I think Kubernetes is great that it orchestrates containers, but I think the real value is that it defines a lot of specifications and standards. If I'm deploying to a Kubernetes-based system, then I have a pretty good idea that there are going to be pods involved. There are probably going to be deployments. I know what a pod looks like. I know what a deployment looks like. And I don't have to worry about those details. And it also makes it so that we suddenly have a system that has an almost infinite potential for extension. If you build a system on Kubernetes and it's using pods, then you don't actually have to give me any plugin mechanisms, because I can actually inject into the system if I want to. I can write an admission controller that actually changes those pods. There's an infinite potential for what you can build on it. And the reason that that's working is because it's built on these specifications and standards. And it means that I can use whatever tools I like best when I'm working with Kubernetes, and they don't actually need to be the same as the person next to me. And this also means that it solves a question that we've kind of been dealing with for a long time, which is, how do I replicate production? If you're using Kubernetes, then a deployment is a deployment. So that means that you should be able to take your production configuration, and you can more or less use the same thing for another deployment. And I want to contrast this with another job that I had where for several years, everyone on my team developed against the same instance of one of our key services that ran on my manager's VM. And the reason was because none of us could figure out how to set it up. As soon as someone joined the team, they'd spend about a week digging through wiki articles, trying to decipher the way that someone made it work before, but nobody ever did, so we just all used that same service. And so this is a really different problem now. Now we're dealing with a whole bunch of YAML configuration that's kind of frustrating, but the questions are more like, which parts of this configuration are important, which ones can I change? It's not what operating system do I need? Do I have the right version of Supervisor D running? Did I pip install all the right packages? It's much more focused. And even though it's a hassle to define and manage all this configuration, it also means that it's actually written down somewhere. So once you get through the hurdles of actually creating all the configuration, then you can commit them somewhere, and then anyone who wants to can go and see exactly how to stamp out a production cluster. And as we talked about the strength around defining standards, it reduces the amount of things that we have to talk about. We don't have to argue about what a container spec looks like because we already know. So I think that CI should do the same thing. We should define standards around CI that will be the same between different CI systems. And that way we can stop writing the same Slack plugin over and over again for every CI system that we deal with, and we can worry about solving our actual business problems. And if we build our CI systems on these standards, it means that you should be able to create an entire system with one vendor and potentially take the entire thing and move it to some other vendor without having any penalty. Or if you want to, you should be able to pick and choose between the pieces of each vendor that you like the best. And so maybe we all hate YAML. I mean, I think if you've worked with YAML, you probably hate it, or at least you probably don't love it. But at least if I work on a system that's configured with YAML and I want to know how it works, I can go and look at the configuration. It hurts me, but it's there. I don't have to attach myself to a running binary and inspect the system calls to try to figure out what's happening. I can just look at a configuration file. And as our systems get more complicated, it's more and more important that everybody who's working with them be able to actually understand and decipher what's going on. And when you're working with CI, when something goes wrong, whether it's with the system itself or because there's actually a bug that you need to figure out, it's really important that everybody that's working on it can be able to debug and figure out what's going on as fast as possible. And it turns out that debugging is actually all about learning. If you already knew how something worked, you wouldn't need to debug it. You would just know what was going on, which does happen sometimes. But most of the time, when there's a problem, we have to debug it, which is the act of gaining new knowledge. Debugging is a kind of learning. And the better you are at learning, the more effective you are, and the faster you can deliver value as a software engineer. This is a tweet that I really like from Ali Spatel. It suggests that maybe the ability to teach yourself new things is the most important skill that engineers can have. And I think especially as things like cloud native give us a lot of benefits but make things much more complicated. And it's probably only going to get worse. But if you can debug, then you can learn, and then you can keep up. And so how do we debug? We do it by looking at something and by reading how it works, by trying it out, by making little changes, by seeing what happens, by investigating it. I once went to a lightning talk where the speaker was talking about his method for learning when he started a new job, and he called it being a trash panda. If you're not familiar, trash panda is another name for a raccoon. But the idea was that you can learn by digging through all of the information that's available to you. So when I want to start using your project and I want to learn about it, if I can't find what I'm looking for in the docs, I'm going to start looking at the configuration. I'm going to look at your Docker files. I want to see how your CI works, because all of that will show me how your system actually works. And so that brings me to Tekton, which is the project that I work on. And I think it's a great, I'm very biased, but I think it's a good example of cloud-native CI/CD. And so I'm going to talk a bit about what it is, how it works, and why I think it fills those requirements for cloud-native CI/CD. So first of all, it is built with Kubernetes. Who here is familiar with CRDs? OK, so like quite a few people. Whether you're familiar or not, a quick overview. So CRD stands for Custom Resource Definition. And it's a way of extending Kubernetes. So out of the box, Kubernetes comes with resources like pods and deployments. But with a CRD, you basically can add your own types into the system. And on their own, they're just structured data. But then the pattern for CRDs is that you add another binary called a controller, which acts on them. And then together, these make declarative APIs that you can extend Kubernetes with. And the controllers themselves basically will watch all of your CRDs, and when they change state, when they're created or updated or deleted, then the controller is invoked to do whatever it wants to do to realize those resources. If you're interested in building your own controller and CRD, I think these slides are shared with everybody, but these are links to resources you can use. There's kind of two camps for the libraries that you can use for this. One of them is all based around statically generating all the code you need to interact with your CRDs, and the other is based on something called the controller runtime, and it's more dynamic. For Tekton pipelines, we happen to be using Knative PKG because in the previous talk, if you noticed, Knative build was deprecated. Knative build was like the beginning seed of Tekton. So we started out in the Knative project and then expanded from there. So we still use some of their code. OK, so that's how it's built. So what is Tekton? So this is the definition of cloud native CI that we were going through before. It's serverless. There's specs and standards. You don't have to care where it's running. You can reuse pieces of it, and the configuration can be treated as code. So the first thing to understand about Tekton is that it is not the porcelain, it is the plumbing. So this is a phrase that I've heard a lot. If you Google it, you can't really, there's like a Stack Overflow answer to it, but there's this analogy that sometimes with tools, we're kind of like, if you're looking for a toilet, you probably don't, and you just find the plumbing that is like underneath the user interface of the toilet itself, you're probably not going to be very happy unless you happen to build toilets. So basically, in this analogy, Tekton is the plumbing. It is not the porcelain. So if you're looking for a porcelain CI experience, I would not recommend that you come to Tekton right now. You're just going to be very sad, which raises the question of who is Tekton actually for. So there's kind of three different groups of people. At the moment, the people who would be best suited to working with Tekton are people who want to build CI systems. So this is both people that are making systems like Jenkins X, but then also if you work in a company where you kind of need things to be fairly bespoke, and maybe you have a team that's dedicated to sort of your release process or your developer experience, then something like Tekton might work really well for you. Or if you just like to tinker around and you want something that's very DIY, then you could use Tekton. Eventually, we want to provide a catalog of reusable pieces that would appeal to anyone, even the people that are looking for the porcelain. But that part is kind of very new right now. So basically, if you are not wanting the DIY, then maybe just be aware that this is happening and kind of observe it from afar. But if you are looking for DIY, then this is a great time to get involved because you can actually help shape it in the direction that works for you. So how does it work? The most basic building block is a step. A step is actually an image with all of the arguments that you need to run it. And this is a Kubernetes concept that exists already. The first custom resource that we added is called a task. A task runs steps in order. So this means you can say, I want these images to run. I want this one to run before this one. They all run on the same node, so they share disk space. What if you need to do more complicated things? So the next new type is a pipeline, which combines tasks. So with a pipeline, you can run tasks in any order you want. You can run them sequentially. You can run them in parallel. You can create really complicated graphs. They all run on different Kubernetes nodes, or they're not guaranteed to be on the same node, so you don't have the same disk space guarantees. But you can take the outputs of one and provide them as inputs to another. So those two types you define once, and you use them again and again. To actually run a pipeline or a task, you create something called a run. So a pipeline run runs a pipeline. A task run runs a task. And then our last new type is called a pipeline resource, which provides parameters to those runs. So this is what it looks like all together. We have tasks that are made of steps. Pipelines are made of tasks, and then we run them with pipeline runs and task runs, and we provide runtime information with pipeline resources. And so this is kind of going back again to that definition of cloud native CI. I think Tekton fills this well because all of the execution is serverless. The only thing that's running in your system is the controller binary. As soon as you want to run a workload, then a task run is created, and then the pods are created to execute that, and then they're removed afterwards. This is all based around an API that's being developed with a bunch of partners in the open. The building block is a container, so if you can run a container, you can run the pieces of Tekton. And then since we're basing this around these specifications for tasks, pipelines, and pipeline resources, those components are reusable and they're YAML, for better or worse, so you can just commit them to your repo and treat them like you treat other code. Okay, so now I'm going to do a demo of this in action. I have to change my, no, where's my display configuration? If I'm not mirroring this, it is not going to work because I will not be able to see anything. No, well, that's part of it. Okay, hold on a second. Just think about lunch and how delicious it's going to be. Okay, here we go. All right, so I'm going to show you updating a deployment of a service that's running in Kubernetes using Tekton. So I have 2 GKE clusters, so that's Google Kubernetes Engine? Oh no, I think, which is where I'm running Tekton and my service. So let's take a look at the service that we're going to update. So that is running with Istio. And this is my service. It's my beautiful cat service. This is my cat. She's like getting older, so I'm trying to put her in everything I can. Anyways, okay, so let's make a change to the cat service. So let's say that I want to change the image, and I'm going to change some of the colors around because it's not Christmas anymore. So let's say, black, and we'll make the background something else. Picking a color is the hardest part. Just put something in there. Okay, blue. And I will try to, okay. Now we're going to commit that change and push it. So I'm going to push this to a branch. And then now I'm going to, so I'm going to start this running, and then I'm going to talk about what's happening afterwards. Start. Oh no, not that tag. No, don't start. I hope that didn't start. That was a typo, but we'll go with it. 45, sure. Okay, so I just started, that created a pipeline run that's running in the background. So let me show you a little bit of what's happening. So custom resource definition. So as I was mentioning, this is all done with custom resources in Kubernetes. So I can just take a look at my cluster, and I can see that there are all these types, some of which I didn't talk about, but the ones I did talk about, like pipelines and tasks. And I can interact with these with Kubernetes, with kubectl all I want because they're Kubernetes types. So I can do stuff like get the pipeline runs, because I just started a pipeline. You can see like all of these ones, and like here's the one that's running. So I can take a look at the miles and miles of YAML that define this thing. Oh, it's so much that's not even showing it. Let's pipe that in. Look at the YAML, the beautiful YAML. It keeps going and going and going. And then behind this, there are several pods. So I can get some of those pods, and we can take a look at them if we want. So like here's a pod, more YAML. This is the YAML that defines the pod. This is even longer. There's some like magic happening in here too, which if you're interested in, come to my talk at KubeCon in North America. I'm going to talk about how this works. Anyway, so all of this is running, but I don't actually, because of the way that this is defined on standards, I don't actually need to interact with it that way. Instead, I can use, we have a CLI tool called TKN that will show us all of our pipeline runs, and we can use it to follow the logs if we want. If I can remember how to use it. And the cool thing about having a standard like this, or a specification like this, is that as long as so if anyone's using Tekton and they're complying with this specification, then you could use the same tool with whatever instance is running. So right now it is building an image. And behind the scenes, I'm actually using Istio to host my service. So I'll show you just the tiniest little taste of how that works. Virtual, no. There, okay. Sorry, that was just my demo sound. Okay. So at the moment, I'm directing 100% of my traffic to my production service, which you already saw. So I'll show you that getting updated along the way. But let's take a very brief look at the Tekton pipeline that we're using for this. So this is the pipeline. It's a lot of YAML again. But one thing that's cool is that right off the bat, I can kind of get a sense of what's happening because I can see all of the inputs that need to go into this pipeline. So I can see that it's going to take a tag, which it's going to use to tag the image. I know it's going to do something with a Git repository. It's going to do something with an image, and it's going to do something with a Kubernetes cluster. So before I even try to invoke this CI, I know that I need a Git repository. I probably need to be able to push an image somewhere, and I probably need a Kubernetes cluster that I can interact with. Another cool thing is that when I ran it, all I did was run that tool, and I did start, and I provided these parameters to it. But let's say that I started on this team and I didn't know anything about Istio. And in fact, I think I forgot everything I learned about Istio since I set this demo up the first time. But I can still run the pipeline, and I can do a canary deployment with Istio because everything's set up for me. And if I did want to learn more about Istio and how it worked, I could start poking at the pipeline and see, like, oh, what tasks is it running to do this canary deployment? And then I could start looking in the canary deployment tasks, and I could start seeing, like, the kinds of resources that are being changed and what's being changed. And I could actually use it as a tool to learn more about Istio if I wanted to. So now the canary rollout has started, and we now have 10% of our traffic going to the canary service. So if I go over here and I refresh, there's like a probably not quite 1 in 10 chance, but like something like that. Come on! There! Yeah, okay. So sometimes we'll be hitting the canary service, sometimes we'll be hitting the production service, and then this rollout is going to continue. It's going to shift more of the traffic over to the canary until it's done. Now it's 25%, so you can see down here, this is the change it's actually making in my cluster. So anyway, so that's kind of, this is fairly contrived because it's not actually monitoring the health of the canary or anything like that. It's just kind of showing you the sort of thing you can do. Is that the 30-minute alarm? Oh no, I lost my timer. Okay. Okay, well, so that was the demo. I'm going to finish off by telling you what's next for Tekton very briefly. So this is a community effort. We have regular contributions from Cloudies, from Red Hat, IBM, and Salesforce. We've also put a lot of effort into making it really easy to ramp up. So if you're interested in contributing to this project, please come and join us. These are, if you look at the org, there's several different projects you'll see in there. These are kind of some of the highlights. There's the pipelines project, which is most of what I talked about today. It's the core around the pipelines and the tasks. Then there's the triggers project, which it hasn't yet had a release, but we'll be having a release at the end of this quarter, which is all about being able to hook up, having so that when I did that push to GitHub, like it automatically will run the pipeline instead of me doing it manually. There's the catalog, where we want to have the reusable components. And then there are community-driven UIs for the CLI, which you saw in the demo, and the dashboard. So we're working right now on doing our first release of the triggers project. We're working towards a beta release of Tekton Pipelines itself. Next year, we're going to be focusing a lot on the catalog. And then adding in other cool functionality like manual approvals is something that we're asked for a lot. One thing to note is that there's nothing stopping you from doing any of this right now. It's just that there's no like good abstraction around doing it. So you can do, whatever you can do in a container, you can do in Tekton. But we just want to have higher level support for advanced CI/CD features. Also, we've donated Tekton to the Continuous Delivery Foundation, which is a new foundation that was announced earlier this year. It's in there with Jenkins, JenkinsX, and Spinnaker. So if you're interested in more, tekton.dev has very little information, but one day we'll have more. You can take a look at the pipeline repository. If you're interested in getting involved, we have a community repository where we have info about our working group meetings, our mailing lists, our calendar. And then there's going to be an event at KubeCon North America on the day before. It's the CDF Summit. And there's some links if you wanted to sign up for that. You have to be attending KubeCon. It's like an extra thing you can register for. And there's some sources. And so that's it. Thank you very much.
That was amazing. I want to join Tekton already. I honestly look lot of information. There was not much, so I'm so happy that we were able to bring you over and introduce people to tekton, and hopefully, see how the project built up and make it more easier to use by end users. And as you said, right now it's more for building solutions right on top. So thank you very much. I'm going to put the schedule for the lunch and what's going to happen in the next hours. All right, so the lunch area is over there, so you can go grab your lunch. We have like maybe 30 minutes or so before things are going to kick off. So at the lunch, please make sure to take a picture, because there will be no more photo booth. There will be a lot of kiosks. You can get swag. I'm going to be giving Kubernetes, CNCF, stickers, whatever, so you can pass by the area. And then, yeah, so the next Easter workshop starts at 1. There will be the talks on the machine learning track, and here you're going to learn about Anthos, and there will be CI/CD talks and whatnot. So enjoy your lunch, and we'll see you like in 30-40 minutes.